Hello, and welcome to the ITRS Tech Update webinar. Thank you for attending. Today's session is the latest in a series of quarterly ITRS client webinars. We will focus on different aspects of monitoring, support, and observability. On March 3rd, 2006, Amazon began offering IT infrastructure services to businesses in the form of web services. While data center and IT hosting providers had been offering the concept of remote computing for years, the generally accepted notion of the cloud was born with AWS. In the ensuing 17 years, the cloud has become routine in our daily lives. Even the most non-technical among us knows that they store photos in the cloud and they do banking in the cloud. In financial services, cloud adoption has been measured, but increasingly in velocity and momentum to the point of no return. As application and business processing are migrating to or being developed natively in the cloud, the need for proper monitoring has only increased. The major cloud providers offer rich data and metrics about their service and your use of that service. But information tends to be cloud infrastructure focused and cannot be designed to your specific application and process monitoring needs. Today we will discuss two powerful offerings from ITRS: cloud integrations and the Forecaster app. Our goal today is to inform you of our expanding technology offerings and how they can be applied in an ever-changing tech landscape. We have two exciting topics to share today, brought to you by our product management team. First, we will start with a brief introduction to ITRS's public cloud integrations, focusing on AWS and Azure. Loki Balakrishnan will guide us through the cloud monitoring segment. Next, we will highlight our new forecasting application as part of the Obcerv suite. Ian Flockhart will be presenting the forecasting app portion of today's webinar. This webinar should provide insight into ITRS's latest offerings to address emerging technologies, as well as demonstrate trends within the industry and our client base. Just a few housekeeping notes about the webinar. At the conclusion of Loki and Ian's presentation, we will be hosting a brief Q&A session. Please submit questions at any time during your presentation in the designated question box in your webinar frame. We will collate the questions and put them to our presenters at the end of the webinar. If we do not answer your question, please feel free to contact your account representative, support relationship, or you can find us on LinkedIn. This webinar is being recorded and will be made publicly available. A link will be posted on our website, itrsgroup.com. Thank you and enjoy the webinar. And with that, I present Loki.
Thank you, Michael, and welcome everyone. As Michael said, the migration towards cloud has been with us for many years now, but it's fair to say there's an increased focus primarily driven by the move towards container-based and microservice architectures. So it's very likely that the big enterprises will remain a hybrid for years to come, meaning not everything will move into the cloud for lots of good reasons. When we talk about migrating to cloud, for most people, it typically means one of three things. The first option is, you're looking at a full lift and shift, meaning you're running a VM on-prem at the moment, and you can now move that to run in the cloud. Virtually no changes to application, so naturally, this is the least effort in terms of moving to the cloud. In terms of application monitoring, not a lot changes for this option. If you had a NetProbe running in a VM, you will continue to have a NetProbe in a cloud VM, but you will additionally have need visibility into some of the cloud services for network, firewall, load balancers, storage, etc. The second option is when you decide to make some changes to the application. Maybe the front end is being redeveloped and run completely in the cloud, but you still have the backend components on-prem. This means the front end services can be deployed faster, cheaper, while the backend remains pretty much as it was. So it needs more effort than just lift and shift, but you also have the benefits of being able to move some of the applications onto the cloud. It is likely in this case, you will have a mix of cloud VMs and other cloud native services. So you will still have NetProbes running inside VMs, but you also need to monitor other cloud services like Lambda function, Azure functions, message bus services in the cloud, and application services, API services, and the list goes on. The third option is really the full refactor option, where really you're deciding pretty much to rewrite the application fully cloud native. Clearly, this is by far requires the most effort. And in this case, it's very likely you have container workloads in Kubernetes, like EKS and AKS. So most of the infrastructure is now managed in Kubernetes. So this requires a slightly different approach to monitoring. So you still need to monitor the cloud services, but most of the observability data is going to come from the Kubernetes and the applications instrumented to emit this data using standards like OpenTelemetry, StatsD, Prometheus, etc. So from what we have seen across our client base, lift and shift is pretty much done. So clients already have things that can be moved onto the cloud, are already running in the cloud. I think where we are today is the next sort of two options, especially any new development is more focused on cloud native serverless microservice architectures. So how can ITRS help in the cloud monitoring? So today we are looking at Azure and AWS, two of the most popular options, but we also have integrations to Google Cloud, and we continue to work on all three platforms, so there are always more updates in the pipeline. We support many of the common services across these platforms, from compute, storage, messaging APIs, databases, functions, and many more. We collect metrics, events, and log data via a couple of methods. CloudWatch API and Azure API are the quickest way to get metrics. We also support Events Bridge in AWS and the Event Hub in Azure to aggregate events, logs, and then stream them out to the NetProbe. So in large cloud environments, making API calls to get all your metrics can start to hit the API limits. So Event Hub option in Azure, for example, also supports streaming metrics out via that method rather than using the API calls. Another advantage of aggregating data in services like Event Bridge or Event Hub is that it gives you more control over that data. Often there is just way too much data. So being able to filter and decide what's important upstream will make it will help you to build a better observability. The last one, we are available on both the Azure and the AWS marketplace. This is a quick and easy way to get started, to get NetProbes and gateways deployed in a VM that is pre-configured to monitor the cloud. We'll go through that in the demo a little later. So why use ITRS cloud monitoring? Lots of good reasons, but I think fundamentally it's the same reason why you have ITRS today. It lets you consolidate monitoring and observability data across a wide technology stack, from market data to infrastructure on-prem and in the cloud, to applications running in your AIX servers, to your containers in Kubernetes, and monitoring the online digital experience from the client's point of view as well. So there is huge value in bringing all this data together in an increasingly sort of hybrid and multi-cloud environments, to have that single pane of glass view is important. Our cloud offering, the plugins, use the dynamic entities concept, meaning we collect self-describing data points with dimensions and attributes so that we can dynamically create entities to monitor. So as your cloud usage scales up and down, the monitoring automatically scales with that. So with a little bit of configuration up front, you can get a fairly automated monitoring setup. As always, the flexibility is there too, to customize what you want to collect and how you want to visualize the data, as most Geneos users are accustomed to do. Right, I think that's everything on the slides. So I'm going to switch to demo. Let me just switch over. I have a couple of gateways, one monitoring the on-prem data centers. The other is a cloud gateway running in a VM in Azure, currently configured and receiving metrics, events, and logs from the Azure cloud services. Now, both these gateways are publishing data to Obcerv. So for the rest of the demo, I'm going to switch over to Obcerv and see if you can work through that. Right. So for those not familiar with Obcerv, it is our observability platform for bringing metrics, logs, events, and soon trace data together into one platform, so you can go from monitoring to full observability at scale. I'm sure we will have further sessions for a deep dive into Obcerv, but for today, I'm more focused on cloud monitoring and how we can bring data from multiple cloud providers, on-prem data, together to support the sort of the hybrid environment that most users are using today. So what you're looking at is the system overview app in Obcerv. Think of it as your view path, state tree, and metrics view combined, with much more flexibility to build your own view of the system that you're looking at. You can see here entities from the Kubernetes. So we are monitoring the pods, nodes, and containers. So this is coming from the Azure Kubernetes service, the AKS, and we have an NetProbes and collection agent deployed in Kubernetes to collect these metrics. We can click through from the entities and get a list of metrics, and we can see severity events. We can click through from the severities to see the alert history. We can expand the alert history to see a bit of history as well. So Obcerv platform does give you that history as well, going back in time. You can see a history for a longer period of time. As you can see, there's a good reason why that metric is in a critical status. So let's switching back to system overview. We can also see we got the data coming from Geneos being published. That is the normal entities monitoring the data center. And we also have the Azure data coming through as well. So you can filter this. The status. The status bar here is a really good way to keep an eye on the overall aggregated status of the systems that you look at. So for Azure, that gives you a timeline and an overall aggregated status of what's happening. We can drill through this. We can rearrange the data here. We got some dimensions and attributes coming through from Azure. We can regroup them. We can change them around. So let's say, let's look at just by the resource provider. So we can see network metrics, compute, key vault, storage. It gives you that flexibility to arrange the data in the way that you want to see it. We can click through and see the metrics as well. Now, what I haven't got in here yet is the log data. So let me just switch over to the Azure portal, where we can go and see how we get some log data into Geneos. Right, let me switch over there. Right, I'm going to use the Azure Key Vault service in Azure as an example to generate some audit data, audit activity essentially. We have some test keys and secrets and certificates created. Let's go in and create and maybe delete some keys just as a way to generate. Oop, that one's already exists, I guess. Right, we'll create one. We'll also delete a couple of keys as well. Let's delete that one. Let's delete that one as well. So like most Azure services, it allows you to configure diagnostic settings. So for this service, I've configured diagnostic settings to publish the audit activity via the Event Hub stream to the NetProbe. So to be honest, if you have to set up each service to export data out via the Event Hub, this can be a lot of configuration on the Azure side. But thankfully, this can be automated. So you can use things like Azure ARM templates or Terraform to automate these configurations. So you don't have to do it per service. But in this case, I've configured the diagnostic settings so that audit logs are being published via the Event Hub to the NetProbe. So the activities we just did should generate some log data. And I have NetProbe configured with the FKM plugin that can receive that log data and those events and trigger on specific events like deleting a key, for example. So we should hopefully see some events being generated or severity events coming through for that delete audit event. And all the data that is published from Azure via the Event Hub to the NetProbe is also published to Obcerv. So you have the event and log history alongside the metrics as well. We'll go into that in a bit more detail later. Now, but first I want to switch to look at how we can deploy NetProbes to monitor the cloud services. So we already have the Azure covered. So you saw some metrics coming from Azure service. So let's deploy a NetProbe in AWS to get some metrics. Now, the easiest way to do that is using the marketplace. So that's the AWS marketplace. Let's go and search for ITRS. We'll click through and subscribe for that. It is a bring your own license, so you do need an on-prem license daemon in order to run the VM with the NetProbes and the gateways, or you can run in a demo mode as well. If you just want to run it up quickly to see what it looks like, then you can do that without any license requirements. All right, let's click through. We can take pretty much all the defaults. I'm just going to click through this. We do need to launch this in an EC2 portal. Reason being, there are a couple of settings we need to do, advanced level settings we need to do in order to provide the right credentials and also provide some parameters that the NetProbes and the gateways need to work. So let's do that. Let's just call this AWS collector. We can leave all of these defaults as they are. I'll just select a key, maybe one of my keys. Oh, not the one thing. Oh, never mind. We can leave all those defaults. So in the advanced setting, there are a couple of things we need to set up. One is the profile. So this is something that you probably need to set up with the help of an admin. Essentially, that profile needs to have the correct level of permissions in order to make the API calls to pull the metrics from CloudWatch. So that's something that you need to set up in advance. And then as you create this image from Marketplace, then you can just pick the right profile and then you'll be up and running. One last thing we need to do is to provide some user data. Let me copy and paste something from, yeah. Really, it has, there are different modes you can run this. You can run in this VM, you can run both NetProbe and the gateways. In this case, since I already have a gateway, I'm just going to run the NetProbe, and I'm just saying the regions I want to monitor and the gateway that I want to connect to, so that when that VM gets deployed, when the EC2 gets deployed, the NetProbe comes up, it connects to the gateway, and you should hopefully start seeing some data. So let's launch that. Now, while that's deploying, let me show you what the Azure deployment looks like. Now, Azure has a very similar process. Again, we have the marketplace offering, so you can come here and search for ITRS. And just click through to create an Azure VM. Again, that will have the same options as AWS, whether you can run a NetProbe or you can run NetProbe in a gateway. And again, you need to provide it the credentials to connect to the Azure Monitor API, and also you need the parameters to run the NetProbe. So things like I think you can take pretty much all the default configurations, and in the advanced tab, you can put in some custom data. In the case of Azure, you can actually pass the credentials via the user data or custom data. I guess it's not as secure as the AWS option, which looks at your profile and gets it from there. But this obviously makes it slightly easier. You can pass those credentials straight to the plugin and not have to set up essentially necessarily a profile to do it. So I'm not going to create this VM since we already have Azure monitoring in place. Now let me switch back to Obcerv. Now let's find the AWS metrics that they should be starting to come through now. So let's go and create a new group. And one of the AWS dimensions is a namespace. So let's look for a namespace. And here we are. We can see we've got EC2, EBS, S3, EKS, all those data coming through. Let's see if we can put a region as well. Okay, it probably makes sense. Region first, and then the namespace. So again, you can drill through and see the metrics in the same way I showed you earlier. Now, one thing we haven't looked at is the audit data that was meant to come through. So let's have a look at the Azure. Oh, we do have a severity being generated. We can see there's a fail audit event. We can click through and open that up. There is some match keys, and this lets you go from system overview. You can switch to the logs, where you can go see the details of what the event is, and then this should hopefully be the delete key events that we generated earlier. You can switch to let's open a split screen, and let's just see if we can see any more activity. So let's say you're going to search for the resource provider is the key vault. See if you can find any activity happened before that delete. As you can see, there's lots of activity, lots of requests and delete. So really, this really lets you, have your metrics in place, look at the metrics, drill down into your metrics, see the history of your metrics, and then also come and look at events and log data on the same platform. So hopefully that gives you some idea of the cloud monitoring solution. So that's everything from me for now. I will hand over to Ian to talk about the Forecaster app in Obcerv, a great way to use historical data to predict if metrics are likely to breach a threshold, for example. Over to you, Ian.
Thank you, Loki. My name's Ian Flockhart, and I'm the product owner for the Forecaster app. Now, the Forecaster app generates real-time forecasts from time series data. It's aimed at improving operational resilience and incident prevention by giving advanced warning of metric time series that are trending towards a defined threshold limit. Firstly, let me put the Forecaster app in the context of the wider Obcerv platform. Obcerv is ITRS's observability and monitoring platform, which provides full 360-degree stack visibility. Obcerv gathers data from infrastructure, application, and digital experience monitoring systems, as well as logs and other sources of data, and gathers them into one place, creating an information resource on which we can build a range of vertical and horizontal applications. Within Obcerv, Observant is the umbrella name under which our anomaly detection and prediction algorithms reside. It's called Observant because it will constantly observe your data 24/7 and highlight through signals and alerts information that is worth paying attention to. Forecaster is the first of these apps to be released. It creates real-time forecasts based on historical values of a metric time series and generates signals to the alerting app if a value is forecast to cross a defined threshold within a specified future time period, or alternatively if the value has actually crossed that threshold. Forecaster is based upon the theta forecasting algorithm. It allows control over the look-back period or training period on which the forecast is based, the granularity of the data used in the forecast, and how far into the future the forecast should be made. You can also control the thresholds at which warning and critical signals are generated and choose whether values above or below the threshold should generate a signal. There are multiple use cases for Forecaster. Perhaps the most obvious is incident prevention. By detecting early the resources that are growing towards capacity limits or that are decreasing towards exhaustion, we can be proactive in our operations and resolve issues before they turn into incidents. Typical examples of this include storage drives running out of space, applications with memory leaks gradually consuming all available memory, increases in CPU consumption over time that might otherwise go unnoticed. We can also use Forecaster to detect and forecast trends, for example, deterioration of response times or growth in business volumes. And Forecaster can also be used retrospectively to look at a data set and Forecaster can also be used retrospective analysis and continuous improvement. It allows us to go back in time and examine what forecast would have been generated compared against the actuals that did occur. So that means that we can look at historical incidents and ask the question, could we have detected this if a forecaster rule had been in place? And if the answer to that question is yes, then we can add one to improve our incident prevention process for the future. So just looking at the example images here, the top image is showing a throughput metric that has some growth and some periodicity which the forecaster has been able to pick up. The middle image is a typical storage drive trending upwards over time, and it's forecast to breach the warning threshold in around a week's time. And the last image is showing a broadly stable CPU pattern where the forecaster has been able to detect the periodicity of the series. Now, the forecaster does have some limitations because no model will work in all cases. Firstly, forecaster will revert to a linear model if no regular periodicity can be found, but overall growth trend can still be detected. Secondly, if a series is already very close to threshold limits and has a lot of variability, then the forecast model may generate too many threshold breaches. In such cases, it doesn't take much error in the forecast to cause a signal to be raised. And you can see that in the image here in the lower right. This series is actually already above the critical threshold, but let's imagine that threshold had been set at 100%. Then the forecast here is suggesting that 100% would be reached, while the historical values show no obvious indication of utilization getting higher. But it does have a lot of variability and it is close to those limits. So no algorithm will work in all cases. Now with that, I will depart out to a demo. So first of all, if I navigate down to the Observant app, I can see a list of all the forecaster configurations that are already set up. To create a new forecast configuration, I click on the Add button. I can now choose a set of resources over which the configuration should apply by clicking the filter and defining a condition. Now, these conditions are based upon the attributes and properties that are stored in the database. So in this example, I'll pick my pre-sales servers, and I'm going to look at a CPU metric, load average. And when I've chosen both a metric and a filter, it will display a list of entities that match those conditions. So in this case, any entity within the pre-sales department that has a load average 1 minute % metric. Now, some of these servers, let me just adjust the screen size there. I think, yeah, you can see that all on one screen. Some of these servers will have fairly stable utilization. This one has close to 0 utilization. I can page through all the entities that exist. Let's take a look at this one. So in this case, we've got utilization around about 10%, and some of the periodicity of that variation has been picked up by the forecast down here. And we've also got this one, so the pre-sales server. Again, we've got some evidence of periodicity there, and the forecaster picked up some of that. So what changes can I make to this? Well, I'm able to control how far back in time the forecaster will look in order to make a prediction. So by default, it's 1 day here, but I can make that a longer time period of 7 days. And I can also choose a look ahead period. So as soon as I've chosen a threshold warning limit, I have the option here of lengthening this to a longer time period. So if I choose 7 days, then that's going to give me a 7-day ahead forecast. I also have control over the granularity that's used in the forecast. So it will choose one by default, but it's also going to give me lots of alternatives here. Now, this data could be arriving at 20-second intervals or less. So we need to aggregate that to some sensible level. And the choice of aggregation will determine how much noise is seen in that time series. And in actual fact, if we're trying to pick time trends over a long period of time, a fairly chunky bucket size is probably more helpful because it cuts out some of the detailed variation in the series and allows us to pick up the general trend. So here we've got a 3-hour series, and that's looking more like a reasonable forecast now in terms of the way it's picking that up. So I've got control over all these things. I can add a critical limit if I want to add a second threshold. And once I'm happy with the series, with the configuration as it's been set, I can give it a group and a name and then save it, and it will create the configuration, and that will then appear in this list here. Now, I'm not going to create a new one because I've actually created one that's of that nature already previously. But let's have a look at one of the examples saved earlier. So again, we get a multi-page around all the different entities that match this criteria. This C drive here on the Nuka machine, this is a great example of the kind of server that we like to see in operations. Nice and quiet, and behaving itself in a very flat line pattern, not running out of space, not growing, not getting smaller. Nice stable system. We also have examples in here of servers doing other things. So this one here, this Stix C drive. So this one is an example of a server where we've got some variation in the trend. And it still looks fairly flat at this point, but the forecaster has picked up some of the periodicity of that variation. Another interesting thing I can do here is I can actually roll back the time slider here and see what the forecast would have looked like at a previous point in time. And I can see that in the past, this server has actually had higher utilization as it's been coming down the way. And when that was happening, the forecaster was forecasting a decreasing trend. And we can see that level out as time goes by. And it finally catches up with the new trend that is more flat. And if that, if that drive starts to fill up again, then the forecaster is going to pitch upwards and give us early warning that that trend has happened. Okay, here's another time series. This one's on a Linux server, the root folder. This is actually really typical of the type of pattern we see across storage drives. We've got a very slow, gradual increase in utilization over time. And again, I can see that it's going to hit a threshold at some point. If I add an extra couple of days here onto the forecast period, I can actually see if it continues on current trend, more or less the exact date that this is going to hit threshold limits. In this case, around about the start of April, if it continues at that rate. And this kind of forecast has actually been in our capacity planner product for some time, and this has been found to be one of the most useful features in terms of preventing incidents. Okay, got one more server I want to have a look at here, which is in this D drive of Nuka. So again, this is an example where we've now got a pattern that is back on the increase. It looks like this has already had a historical incident, so we'll look at that in a moment. But I can see again that this is on a slow rise once more up towards the capacity limit. And again, it's telling me that this server would hit capacity around about, or would hit the warning limit threshold around about the 6th of April. Once again, I can just reduce the size of that for rolling back here. I can go back and roll my time slider into the past and ask the question, well, this historical incident, would I have been able to predict that? And I can go all the way back here to, mid to late February, and the trend was apparent at that stage. We can see the forecast, the dotted line here, the forecast showing an increase, and it would have said that, by the 27th, 28th of February, this is going to hit the warning threshold. In actual fact, it was about 6:50 on the 28th of February that it hit that threshold. So in this case, again, we could have detected that pattern around about a week early. And that's all I want to show on Forecaster right now. If you're interested in more of the technical details around the Forecaster, you'll find more documentation on our ITRS documentation site. And just navigate to the Observe Forecaster section. and that will tell you some more information about the forecaster on a technical level. And with that, I think we have time for questions and answers.
Yeah, we do. Ian and Loki, thank you for your presentations. Those were excellent. And we got some, very good information on cloud monitoring and the ability to run trending analysis on your data now. So that's just, good information and good things coming through the pipeline here. We do have a few questions, and I think they're about evenly split between our two presenters. So I'll kick one off to you first, Ian. The question is, can you track downward trends?
Yes, you can. Now, the version that I demoed doesn't show that. So let me just show that. So the version that we were looking at, the version that we were looking at doesn't have that option. But I have actually got Loki's. Yeah, this is Loki's environment. So this is the environment that then actually was set up, that Loki was using for his presentation earlier. Now in here, this is a new release of the Forecast app, and it has a threshold toggle here that you can choose above or below. So if we've got a metric, I don't know if we've got something that might be, let's take a look at containers. I wonder if we've got something useful here. There's timescale. Let's have a look at that. So if I find keep container memory free, there's that would be a downward trending metric typically, and it's got a downward trend on it, which is good. And I can change that to when below, and then when my threshold comes up, I can set a threshold that is below. So let's say I want to do it when it's 100, below 100. Oh, it's in megabytes, so let's give it an extra 0. Okay, so I can choose my thresholds accordingly. And the forecaster is going to trend in a downwards direction, and will trigger the signal when
very nice.
crosses this point.
Great. Good to see. Good to see. And I guess the next question I have here, Loki, I'm going to switch it over to you. If I can't access the marketplace in our production environments, can I still run the cloud monitoring plugin? Is the question.
Yeah, absolutely. You can deploy the plugin as you normally do. Have a self-announcing net probe configured to do that. The only difference, marketplace just makes it easier to get started because you got it's pre-configured, and so you can get up and running quickly. But you can apply the same configuration. You can download a net probe and deploy it into a VM in the normal way that you would do. So yeah.
Okay. Good. And I'm just going to come back to you real quick because we do have as we always get it sounds like a roadmap question here. Where are we with the Google Cloud integration? That's for you, Loki.
Yeah, so we do have an integration at the moment, but we know that is not as good as we want it to be. So we definitely have something on the roadmap to rebuild that integration. So we will have something similar to Azure and AWS. So I reckon, within 3 to 6 months we should have something.
Okay, so in the pipeline and being developed as we speak. That's good to hear. Okay, thank you, Ian. Back to you again. What if a capacity for a metric is displayed in another metric? Can I use it in the calculation? I hope that question is kind of clear.
Yeah, I think so. Again, that's probably something that I neglected to demonstrate. There is a capability of using not just a value as a threshold, but a metric. So if I choose a metric value, then I've got the option of specifying another metric in here if I have one available for that threshold.
Okay. And lastly, Loki, we're gonna end with you from a question standpoint. Can the plugin, the monitoring plugin, be configured to report to a gateway outside of the cloud provider?
Yeah, as long as it can reach the gateway. In fact, in the demo, I had the AWS plugin deployed in AWS was reporting to a gateway running in Azure. So as long as it can reach the gateway, it's fine.
Okay, well, that's excellent. And I think that seems to be the question session here. Yep, that seems to be it. So thank you, Loki, again, and Ian for the updates and the presentations. To the audience, thank you for your attendance. Well appreciated. And once again, following, we are recording this session, so we will be posting the link to the recording of this webinar on itrsgroup.com. Thank you again for attending.